Today, you're going to get to know our neighborhood. But not this neighborhood. Instead, this one. Because if Earth is our home, the solar system is our neighborhood. So let's embark on an exciting journey through the solar system, where you will discover planets that exceed 300 degrees Celsius in temperature, while others are frozen below minus 200 degrees Celsius. You will travel to planets with more than 100 moons. And you'll see the tallest mountain in the solar system, which is over 22 kilometers high, making Mount Everest look like an anthill. And you will find out which planet humans could live on if we ever, need to leave Earth for some reason. So, without further ado, fasten your seatbelt and put on your space helmet, because our journey through the solar system is about to begin. Our first stop takes us to the middle of it all. In the center of the solar system is our star, the Sun. It's a gigantic ball of gas and plasma, primarily composed of hydrogen and helium, where some pretty intense nuclear reactions occur, causing the temperature of its surface to rise to over 5,000 degrees Celsius. But, believe it or not, this is actually the cooler part of the Sun, because inside, mind you, it reaches more than 15 million degrees Celsius. The Sun weighs 330 to 100,000 times more than Earth. It's so heavy, so massive, that, due to the force of gravity, all the planets orbit around it. The planet closest to the Sun is Mercury. It's a rather small planet. In fact, it's just slightly larger than our moon. It's also a rocky planet, meaning it has a solid surface, but it barely has any atmosphere. It takes only 88 days to complete one orbit around the Sun, but it rotates on its axis so slowly that a single day on Mercury lasts about 59 Earth days. Since it rotates so slowly and is so close to the Sun, the daytime side heats up immensely, reaching temperatures of 350 degrees Celsius. Meanwhile, on the nighttime side, being in darkness for so long, temperatures plummet dramatically, reaching as low as negative 170 degrees Celsius. Furthermore, Mercury is so small and so close to the Sun that it has almost no atmosphere. Whatever atmosphere it may have had was completely destroyed by the solar wind, which is a stream of highly charged particles that come from the Sun that can interact with the atmosphere and remove its molecules. Since Mercury lacks a substantial atmosphere, that means meteorites don't burn up before crashing into it, so its surface is covered in craters. With conditions like these, with more than 500 degree difference between day and night and almost no atmosphere, unsurprisingly, it's nearly impossible for life to exist on Mercury, and human life could not exist there. So if we wanted to move away from Earth, this couldn't be our home. The next planet is Venus. It's pretty similar in size to Earth and is also a rocky planet, and it takes 225 days to orbit around the Sun. You might be thinking that since it's farther from the Sun, it should be a less scorching planet than Mercury, but unfortunately, you'd be mistaken. Its atmosphere is 92 times denser than Earth's and is composed of 96% carbon dioxide. On Earth, carbon dioxide makes up only 0.032% of the atmosphere, and as you probably know, it's a major factor behind global warming due to the greenhouse gas effect, where it traps heat from the Sun and keeps it in the atmosphere. Now, imagine what the greenhouse effect is like on Venus, where 96% of the atmosphere is carbon dioxide. Also, days on Venus are even longer than on Mercury's. In fact, it takes Venus 243 Earth days to complete a single rotation, which is longer than the time that it takes to complete an orbit around the Sun. So, you can imagine that the planet's surface overheats significantly, with temperatures reaching up to 480 degrees Celsius. On the other hand, if half of the planet endures very long, hot days, the other half deals with very long, cold nights. Similar to Mercury, temperatures drop drastically on the other side of the planet. But thanks to the warming effects of its CO2-rich atmosphere, the temperature only drops to a rather chilly 45 degrees below zero. At least with such a dense atmosphere, most meteorites disintegrate before reaching the surface. In fact, we see the planet as bright white from space because we can only see its atmosphere. It's impossible for us to see the surface from space. If we were to remove all of its clouds, the planet would look like this. Several spacecraft have managed to land and take photographs, and from the surface, Venus looks like this. If Venus still doesn't seem like a comfortable or habitable place to you, I should tell you that in its atmosphere, clouds of sulfuric acid literally form. This compound is so corrosive that it would eat right through our spacesuits if we were ever on the surface. So, Venus is also not a planet fit for human life. The third planet is Earth. Earth is our home, our habitat. It's also a rocky planet primarily composed of iron, silicon, and oxygen. As you already know, Earth takes 24 hours to complete one rotation on its axis, and 365 days and 6 hours to complete one orbit around the Sun. Since you live here, there are probably many things you already know about Earth, but there are many more secrets and interesting things that you might not know. So if you want to learn more about Earth, this is your channel. We make awesome videos about our planet, videos that will help you understand nature, geology, and human society. So, if you are enjoying this video, don't forget to hit the like button, to subscribe, and to have a look at our other videos. We're sure that you will enjoy them, so if you do, thank you very much. Since Earth rotates relatively quickly, the daytime side doesn't heat up too much, and the nighttime side doesn't cool down excessively. You know Earth has cold places and hot places. In fact, the lowest recorded temperature is -89 degrees Celsius in Antarctica. And the highest temperature ever seen is 56.7 degrees Celsius in Death Valley, California. However, compared to all the other planets, these extremes are hardly extreme at all. Except for these specific cases, temperatures are not so extreme, and the planet's average temperature is 14 degrees Celsius. Because the temperatures are moderate, we can have liquid water, and liquid water is the basis of life as we know it. Without liquid water, life would be impossible. And since Earth is covered in it, it makes it pretty easy to live here. And if we wish to find life elsewhere throughout the solar system, we should look for water. Our atmosphere is composed mainly of oxygen, nitrogen, and argon. Oxygen is essential because it's the gas that most living organisms use to breathe. Carbon dioxide is only a small fraction of our atmosphere. The natural proportion is fundamental to create a natural greenhouse gas effect, an effect that makes Earth warmer than it should be according to its distance from the Sun. But if we add too much CO2 to the atmosphere, we make the greenhouse effect much stronger than it should be, irreversibly affecting natural ecosystems. Earth has a single satellite, or object that orbits around it, which we call the Moon. The Moon, as we know, is quite beautiful and serves as the perfect backdrop for lovers. The fourth planet is Mars. It's another rocky planet very similar to Earth and primarily composed of silicon, oxygen, and iron, just like Earth. However, it's much smaller than our planet, and Mars takes 687 days to orbit the Sun. However, it takes about 24 hours to rotate on its axis. Since its rotation is similar to the Earth's, the planet shouldn't heat up or cool down too much. But I have bad news again. Mars has an atmosphere, but it's very thin with very little gas. So, most meteorites don't disintegrate and instead crash onto its surface. This results in massive craters on its surface. Mars is the planet where the most spacecraft have landed, and they've sent us pictures like these. Being far from the Sun, it receives less heat, so it shouldn't warm up as much as Earth. However, its atmosphere is composed of 95% carbon dioxide, which, as you know, is a potent greenhouse gas capable of trapping the little heat it receives. So it could be a warm planet, right, with all that carbon dioxide? Well, here's the catch. Its atmosphere is so thin, so very sparse, that it can't trap heat as effectively as a denser atmosphere. In reality, on the nighttime side of Mars, temperatures drop to almost negative 90 degrees Celsius, and on the daytime side, the maximum temperature is about 20 degrees Celsius. Not too bad, you might think, like a summer's day. But I said that was the maximum temperature. In reality, the average temperature is negative 46 degrees Celsius. Basically impossible for life. But Mars has something also very notable. Olympus Mons, an enormous extinct volcano that is the tallest mountain in the solar system. It stands at 22.5 kilometers in height, almost 3 times the height of Mount Everest. And the base of the volcano is as wide as all of France. That mountain is huge. That is a Chad mountain. Mars has 2 moons, Phobos and Deimos. But they're not 2 large satellites close to the size of our moon. In reality, they're little more than big rocks. In fact, they could be asteroids that just got trapped by Mars' gravity. Before we go to our next planet, between Mars and Jupiter, there is something incredibly interesting. It's called the asteroid belt. It is a large disk located between the orbits of both planets, composed of thousands of small asteroids that orbit the Sun. It is believed that all these materials could have formed a planet, but the massive gravity of Jupiter, which is huge, would have caused disturbances that would have made the consolidation of a planet impossible. Many of these asteroids are very small, the size of small stones, but there are several that are kind of large. In fact, there are 5 dwarf planets, Ceres, Pallas, Vesta, Hygeia, and Juno, within the asteroid belt. These dwarf planets are basically composed of a core of rock and crystallized ice and dust around it. They're too small to have a hot core, a magnetic field, or any kind of atmosphere. Anyway, we'll come back to the topic of dwarf planets later, because there are more things to tell. So, let's jump back to the main planets. The 5th planet is Jupiter, which is also the largest planet in the solar system. Jupiter is 1,300 times larger than Earth and weighs 318 times more. It's a planet very distant from the sun and very cold, known as a gas giant. It's called a gas giant because, unlike other planets like Mars or Earth, it doesn't have a solid surface where we could land a spaceship. Instead, the hydrogen gas in its atmosphere becomes denser and denser until it transitions without a clear boundary into liquid hydrogen, then metallic hydrogen, and finally, the planet's core would be composed of rock and solid ice. But we can never land on either the rocky core or even the liquid hydrogen because the atmosphere becomes so dense, so thick, that there's no clear separation between them. If we were to drop a spacecraft, it would be slowly engulfed by the layers of the atmosphere while gravity crushes it, making it impossible to return to space. Looking at Jupiter from the outside then, this here is Jupiter's Great Red Spot, a storm that exists in its atmosphere. And it's not just any storm, this storm is larger than the entire planet Earth and has been around for at least 300 years when it was first observed. But who knows if it's been around for centuries or even thousands of years. Jupiter takes almost 10 hours, 9 hours and 50 minutes to be precise, to complete one rotation on its axis, in nearly 12 years to orbit the Sun. As of today, 95 of Jupiter's moons have been identified. Some are quite large, like Io, Callisto, Europa, or Ganymede, which are similar in size to our moon, and others are a little more than giant rocks, asteroids that have fallen into Jupiter's orbit. As you may have noticed, life would be impossible on Jupiter, but perhaps it could exist on one of its moons. Europa is a moon with a rocky mantle covered in water. Being so far from the sun, temperatures are very low, and the water has frozen, forming a thick layer of ice. However, satellites have shown that beneath the ice, there's a layer of liquid water, and where there's liquid water, there could be life. Although, given the icy conditions, there can't be plants or complex life, so if it were to be found, it would likely be something very simple, like bacteria. Traveling to Europa to search for organisms would help us determine whether we are a rare exception in the universe, or if life can form relatively easily. However, regardless of the answer, it's clear that we couldn't live on Jupiter or its moons. So, RIP Jupiter. The sixth planet is Saturn, another cold and gaseous giant that's actually really cool. It's 755 times larger than Earth and 95 times heavier, and it's got some pretty snazzy rings. Saturn only takes 10.5 hours to rotate on its axis, but it's so far from the Sun that it takes 29 Earth years to complete its orbit. Being a gas giant like Jupiter, Saturn undergoes a similar transformation in its dense atmosphere, gradually transitioning from gaseous helium, passing through liquid helium and metallic helium, until somewhere within, it might have a solid core. Therefore, just like Jupiter, attempting to land on it would not really be possible. Saturn has 10 rings around it, composed of millions of small dust and ice particles. But in addition to that, Saturn has a whopping 146 satellites, and who knows if more will be discovered in the future. Just like Jupiter, a lot of these satellites are small, captured asteroids, while others are larger. Titan is a moon slightly larger than our moon. It could, I repeat, could harbor life. Astronomers have identified methane and some hydrocarbons in its atmosphere, gases that are very rare but could result from the presence of life. For example, many bacteria emit methane, and our farts are primarily methane gas as well. Does this mean that complex life exists on Titan? Well, No, not really. Being so far from the sun, the temperature is below negative 100 degrees Celsius, so there might be some methane-emitting bacteria, although methane could also have a geological origin without life on the moon. Either way, we couldn't live on Saturn or its moons. Uranus is the seventh planet in the solar system. It too is another gas giant, 63 times larger than Earth and 14 times heavier. It takes about 17 hours to rotate on its axis, and, being so far from the Sun, it takes 84 years to complete one orbit around the Sun. It also has 27 moons in a series of very thin and dark rings. Uranus has a very dense atmosphere of hydrogen, helium, and methane, beneath which the planet is covered in ice. But be aware that scientists say this is not normal ice as we know it. It's a dense and icy ocean of not only water but ammonia, so dense that it doesn't act like a liquid, but not completely frozen solid either. The atmosphere of Uranus is so dense, as in Jupiter or Saturn, that if we were to somehow try to land in this icy ocean, it would crush us and sink us to the bottom, killing us immediately. So, like the planets before it, life on Uranus would also be impossible. But perhaps the most interesting fact about Uranus is that it's the only planet that doesn't spin on its axis vertically. It spins horizontally relative to its orbital plane around the Sun. So, with that in mind, I like to call it the special planet. Neptune is the eighth planet, and it's another gas giant. It takes 16 hours to rotate on its axis, and it's so far from the Sun that it takes 165 years to complete its orbit. So that means by the time you die, over your entire life, Neptune hasn't even completed a single orbit. The planet is 57 times larger than Earth and 17 times heavier. Neptune also has 14 moons and a couple of rings, but these rings are barely visible. They are very thin, dark, and sparse. Neptune's atmosphere is composed of helium and methane gas, and beneath it, there's once again a liquid ice ocean made of water, ammonia, and methane, without solid ground anywhere on the planet. Furthermore, the atmospheric pressure is so great that it would essentially destroy our spacecraft and crush us inside our spacesuits. So, just like the others, life would also be impossible on Neptune. You may have noticed that the first four planets, the ones closest to the Sun, are rocky planets, which are small with a solid rock surface and a distinct gas atmosphere. On the other hand, the four gas giants planets are enormous, with no clear boundary between the gaseous atmosphere and their dense cores. It seems that during the formation of the solar system, the heavier chemical elements remained closer to the Sun, giving rise to the rocky planets, while the lighter elements ended up farther away, forming the gas giants. However, surprisingly, beyond Neptune, there are rocky planets once again. In fact, until 2006, there was a ninth planet in the solar system, a rocky one out past Neptune. But not anymore. What happened to this planet? Did it get eaten by a space monster? Is it an Illuminati conspiracy? Or maybe the lizard people just wiped it from the records. This ninth planet was Pluto, a tiny planet even smaller than our moon. It is a rocky planet that takes almost 7 days to rotate on its axis and nearly 248 years to orbit the Sun. For a long time, Pluto was considered the ninth planet, a small and peculiar rocky planet at the outer limits of the solar system. However, since 2003, more tiny rocky planets began to be discovered, such as Haumea, Eris, and Makemake. Finally, in 2006, planets were reclassified into two categories: planets and dwarf planets. All these tiny bodies were placed in this new category. It is believed that their origin lies in the formation of the solar system, and they are considered failed protoplanets. But to understand this well, we need to explain the origin of the solar system. About 4.6 billion years ago, in our region of the Milky Way, a nebula, which is a large cloud of dust and gas floating in space, collapsed under its immense weight. Materials concentrated, and due to gravity, the heaviest ones settled in the center, beginning to form the Sun. The large mass of this nascent sun caused the formation of a flattened protoplanetary disk that rotated around it. This is when the planets began to form. The theory of planetesimals is the model that best explains how this might have happened. The force of gravity caused the dust and gas floating around the sun to group together, and as these groupings grew larger, they gained more mass, attracting more dust, gases, and rocks, entering a dynamic in which what were initially just a few particles eventually became protoplanets, and later, planets themselves, forming our modern solar system. While the rest of the larger bodies increased in size as more and more planetesimals collided with them, these small protoplanets like Ceres, Eris, Pluto, Makemake, and Haumea couldn't really grow much larger. Instead of becoming full-fledged planets, they remained as dwarf planets. And probably after their formation in the inner solar system, scientists think gravitational perturbations from larger bodies like Jupiter may have pulled them and launched them to the exterior, out to the outer, dark, and cold edge of the solar system, all alone. That said, being that far away from the sun, there's barely any light and it's very cold, so life on dwarf planets is basically impossible. They have little atmosphere and their temperatures drop to negative 200 degrees Celsius. At this point, you might have realized that the inhabitants of Earth have no place to escape if we destroy our oceans and our forests and our atmosphere. The only thing we can do, the only realistic plan, is to take care of and protect our home. It's much cheaper and simpler than searching for planets millions of light years away, which, in the end, we cannot know with certainty whether we could actually inhabit them or not. So, we need to protect the environment, use natural resources moderately, and incorporate the 5 R's into our lives. Refuse what we don't need. Reduce resource consumption. Reuse everything possible. Repair what's damaged instead of throwing it away. And recycling what we no longer need. Because, my friends, this is our home, and around us, there are only planets with very harsh, unlivable conditions. So, if we want to keep living, we have to take care of the Earth, because there is no planet B. Thank you for watching this video. I really hope you enjoyed it. If you want to know what makes Earth so special, why it can host life, and how fragile and delicate it is, you should watch the next video. If you enjoyed this video, I would ask you to give it a thumbs up and subscribe to the channel. Also, don't forget to hit the notification bell to stay informed when we upload more content. If you want to watch more geography videos or geology videos, here are some that might interest you. So again, thank you so much for watching to the end, and I'll see you next time.